Hello, I'm Ula Does Maths. Welcome back to the second video, and today we'll be looking at something slightly difficult compared to what we were doing before, which was the Cartesian plane. So this time we'll be looking at quadratic nth terms. So as you can tell from the title, quadratic nth terms, it's basically an nth term with a quadratic in it. So that's given in the form an squared plus bn plus c. So it's generally given in the same form as a quadratic, but we're not using x this time, we're using n because that's what we use in nth terms. So let's look at an example question. So for this example question, we are being asked to work out the nth term for the following quadratic sequence. We've been given 4 terms of it, which are 5, 11, 19, and 29. So the first step we're going to take is just like we would with a linear nth term sequence, which is finding the common difference. Now, between these terms, you'll realize that if it's quadratic, it will be non-linear. So the first difference will be 6. Second one will be a difference of 8, and the next one will be a difference of 10. Now there's not anything to worry about. What we need to do again now is find the common difference between the differences we just found. So here we've got a difference of plus 2 and another difference of plus 2. Now what we do is we will represent that as 2n squared. The next step to take is to divide whatever we got by 2. So 2n squared divided by 2 is just simply n squared. Now using whatever you get from that division, so we've got n squared, what we're going to do is generate some square numbers. So let's do this. Let's do 4 times because we've been given 4 times for that sequence. So we've got n equals 1, n equals 2, n equals 3, and n equals 4. Now all we're going to do is just square these terms because it says n squared. So 1 squared simply remains as 1, 2 squared goes to 4, 3 squared goes to 9, and then we have 4 squared going to 16. Now all we need to do here is subtract the quadratic term we've been given, so 5 minus 1, 11 minus 4, and so on. So what we're going to do is do it in such a way, so 5 minus this 1, brackets, so we're indicating that we're moving on to the second differences. So we've got 11 minus 4, then we've got 19 minus 9, and finally 29 minus 16. Now all we need to do is just simplify this, so let's just do the subtraction. So we've got 4, 7, 10, and then we have a 13. Now this is where you'll realize that this will be a linear nth term part of the whole sequence, so we'll get common difference of plus 3 each time. So there we've got plus 3, plus 3, plus 3. All we need to do is treat this like a normal nth term sequence. So we've got a difference of 3n, and then if we move back one step, we will get 4 minus 3, which is a plus 1. And overall, that means that we've got n squared plus 3n plus 1. So the final answer will be n squared plus 3n plus 1. And that is 4 marks awarded for you. Now that we've gone through an example question with the entire method, I've got 3 questions here for you to try, and I will give the answers in 10 seconds. So pause if you want to try them, or else go 10 seconds ahead and I will show you the solutions. So let's take a look at the first question here, and we've got 2, 10, 22, and 38 to try and find an nth term from. So again, let's just start like we did. Difference of plus 8, difference of plus 12, and a difference of plus 16. Now you'll be able to notice from here that we've got another difference we can take out, which is a plus 4. So plus 4. That means we've got 4n squared. The next step will be to divide this through by 2, and 4 divided by 2 is 2. So we've got 2n squared. Same principle as before, we will generate some square numbers using this. So we've got n equals 1, we will go up to 4 again, and we've got 2 lots of the 1 squared. 1 squared is 1, multiplied by 2 is a 2. When n equals 2, we have 2 lots of 2 squared. 2 squared is 4, multiplied by 2 is an 8. When n equals 3, we have 2 lots of 3 squared. Now 3 squared is 9, and multiplied by 2 is 18. And finally, when n equals 4, we have 2 lots of 4 squared, and 4 squared is 16, multiplied by 2 is a 32. And what we are going to do is subtract. So we've got that original 2 minus a 2 from here. We've got a 10 minus an 8. Then we've got a 22 subtracted by an 18. And then finally we have a 38 subtracted by a 32. So let's start simplifying this down by subtracting. So we've got 0, 2, 4, and a 6. Now from this point we will treat it like a linear nth term sequence, so let's just find the common difference. So we've got a +2, +2, and a +2. That means we have 2n. Now if we subtract 2, going back a step, we will get 0 minus 2, which is -2, which means it's 2n minus 2. Put this all together, we've got 2n squared plus 2n minus a 2. So that is the final answer for the first one. Now taking a look at the second question, we've got the terms 2, 10, 24 and 44. So let's start again by finding the common difference. We've got a difference of 8, difference of 14, and then we have a difference of 20. Now again we can find a common difference between the differences. So we've got 8 and 14. Now the difference between those is a +6. The same thing with 14 and 20, so we've got a difference of +6. Now that means we've got 6n squared. All we need to do is divide that by 2, and 6 divided by 2 is 3, so we have 3n squared. Now using that 3n squared, we will again generate some square numbers, so we'll go up to 4 again because we've got 4 terms given in the question. So when n equals 1, 3 lots of 1 squared. So 1 squared is 1, multiplied by 3 is a 3. When n equals 2, 3 lots of 2 squared equals. So 2 squared is 4, 4 multiplied by 3 is 12. When n is 3, we will get 3 lots of 3 squared. So 3 squared is 9, multiplied by 3 is 27. And when finally n equals 4, we get 3 lots of 4 squared. And 4 squared is 16, multiplied by 3 is a 48. Now what we need to do here is just find the differences. So we've got a 2 minus a 3. Then we have a 10 minus a 12. Then we have a 24 subtracted by a 27. And finally we have a 44 subtracted by a 48. So 2 minus 3 is -1. 10 minus 12 is a -2. 24 minus a 27 is a -3. 44 minus a 48 is a -4. Now what we're just going to do is find the common differences. So that's a -1, that's a -1, and that's a -1. So we've got -n. Now what happens when we add? So if we go back a step, if we do this, we will be adding 1. So -1 plus a 1 will give us a 0. So that means we will have this as our final answer. And that will give us a final answer of 3n squared minus an n, and we don't need to write the 0 down. So that's the second question gone through. And the final question was asking us to find the nth term of 19, 15, 9, and 1. So what we will do from here is find the common differences again. So 19 and 15, the difference will be a -4. Difference between 15 and 9 will be a -6, and the difference between 9 and the 8 will be a -8. Now, we haven't got a common difference quite yet, so we're going to do the same thing again between these. So we've got a difference of -2 and a difference of -2. Now that we've got the difference, what we will be doing is -2n squared, and we need to divide that by 2. So -2 divided by 2 will be a -1, and -1 can be expressed as -n squared because we say there's an invisible 1 in algebra. So we've got -n squared to begin with. Now, again, like all the other processes we've done, we will generate our square terms using this -n squared. So when n equals 1, we will get -1 because of the -1 that's invisible in front of the n squared, and a 1 squared. 1 squared is 1, multiplied by -1 will give me -1. N equals 2, -1 2 squared. 2 squared is 4, multiplied by a negative 1 will give me negative 4. When n is a 3, negative 1, 3 squared will give me 3 squared is 9, multiplied by a negative 1 is negative 9. And when finally n is 4, negative 1, 4 squared will give me 4 squared is 16, multiplied by a negative 1 is negative 16. Now again, all we're going to do is just find the differences between the terms we've been given in the question and the ones we just generated. So we've got 19 subtracted by a negative 1. Our next term will be 15 subtracted by a negative 4. Then we will have a 9 minus a negative 9. And finally a 1 minus a negative 16. Now let's just simplify by doing operations. So 19 subtracted by a negative 1 will change the sign, so we've got 19 plus 1, which is 20. The same principle applies for the second one, so we've got 15 plus 4 actually, which is 19. 9 subtracted by a negative 9 will give me 9 plus 9, which is an 18. And finally 1 minus a negative 16 will be 1 plus 16, which is a 17. Now from here we are going to just treat it like a linear nth term sequence here. So we will have the difference of negative 1, and negative 1. So that means we've got negative n, and all we're going to do is just add 1 to these. So we've got an additional term. So if we've added 1, that means we've got 20 plus 1, which is 21. Now that leaves me with negative n squared minus n plus a 21 as my final answer. Now another thing to look out for in GCSE higher tier exams is these questions where there's two parts and one of them is telling you to show that that is the nth term, or you've got a situation where you need to find the term that has a particular value. So let's look at how to answer this one. So for part A, we've been told to show that the nth term is n squared plus n plus 4. So let's start going about this one. So we've got part A. We've got the following terms up there. So we've got 6, 10, 16 and 24. Just need to find the common difference until we've got no more differences. So plus 4, then we've got a difference of plus 6, then we've got a difference of plus 8. Find another common difference, so plus 2 and plus 2. And like before, when we were looking at the general method to find the nth term, we need to do 2n squared divided by 2 to give us n squared. Now again, we're going to just generate some of our square numbers. So we've got n equals 1, which will give us 1 squared, which is 1. N equals 2, giving us 2 squared, which is 4. N equals 3, which will give us a 9. And we've got n equals 4, where 4 squared will give us 16. Same process, we're just going to do some subtraction. So we've got this 6 here minus this 1 here. So we will begin to do that whole pattern again. So we've got 6 minus 1. Then we have 10 minus 4. 10 minus 4. Then we have a 16 minus 9. And finally, we have a 24 minus 16. Like before, we're just going to clean this up by simplifying it down with the subtraction. So what we will do here is 6 minus 1, which is 5. 10 minus 4, which is a 6. 16 minus 9, which will give me 7. And then we have a 24 minus 16, which will give me an 8. Now we're just going to treat this like it's a normal linear nth term. So we've got a difference of plus 1 in all of these cases. So we've got n. And if we move back one step, we will get a 5 minus 1, which is 4. So plus 4. And that means we've got n squared up there and plus n plus 4. So we can therefore state this: n squared plus n plus 4. And because we needed to show that, we will write something such as QED, which says that we've basically done what the question has asked us to do. So that's part A done. Now part B says to find the term that has the value 136. So we know that the nth term is n squared plus n plus 4. So what we will be doing now is n squared plus n plus 4 is equal to 136. Now, as you can see here, we've actually got a quadratic with n being the x terms instead of the x in this case. So we've got n squared plus n, and because the quadratic is always equal to 0, we will subtract 136 on both sides, which would leave us with plus 4 minus 136 equals 0. Now, if we simplify that down a bit, we get n squared plus n plus 100 and... that's a mistake from me. Minus 132 equals 0. So we will get n plus 12, n minus 11. And you'll know that's correct because 12 plus negative 11 will indeed give you plus 1, which will be the n term. So let's have a look if we expand this. So we've got n squared minus 11n plus 12n minus 132. And if we just simplify that middle bit down, we've got n squared plus that n minus 132. So we've got two brackets which will equate to whatever n will be. Now, n plus 12 is equal to 0 from this here, and that means that n is equal to negative 12, or n minus 11 is equal to 0, which means that n is 11. So we've got that, and we've got that as our solutions for n. Finally, for you to try is one question which is similar, and again, you can skip 10 seconds ahead if you want to see the solution, or if you want to try it out, pause the video here and give it a go. Let's take a look at this final question that I've got here for you to try. So we've got the terms negative 8, 2, 16 and a 34. The first part will be to show that the nth term is 2n squared plus 4n subtract a 14. So let's take a look at this. We're just going to look at the same principle, so we've got to look at a common difference. Now the difference between negative 8 and 2 will be a 10. The difference between 2 and 16 will be a 14. And the difference between the 16 and the 34 will be an 18. We still haven't got the common difference, so let's just take it back down here. And we've got 10, 14 and an 18. Now what are the differences? We've got a difference of plus 4 and a plus 4. That means we've got 4n squared, and we should just divide that by 2. 4 divided by 2 is 2, and we've got the n squared, so 2n squared. Now we will be generating some square terms using that, so we will just go up to 4 again. N equals 1, 2 lots of 1 squared will give me 1 squared times 2, which is 2. When n equals 2, we've got 2 lots of 2 squared, so 2 squared is 4, multiplied by 2 is 8. Now when n equals 3, we have 2 lots of 3 squared, so 3 squared is 9, multiplied by 2 is 18. And finally, when n equals a 4, we've got 2 lots of 4 squared. 4 squared is 16, multiplied by 2 is 32. Now, the first and final step in finding the nth term for this bit will be to actually work out the linear part of it. So we've got to subtract the terms. So we've got a negative 8 minus a 2 to begin with. Minus a 2. Then we will have a 2 minus an 8. Then we will have a 16 minus an 18. And a 34 minus a 32. So, negative 8 minus a 2 is negative 10. 2 minus an 8 is a negative 6. 16 minus an 18 will give me a negative 2. 34 minus a 32 will give me a positive 2. Now let's just look at finding the differences in a linear sense. So we've got difference of plus 4, a difference of plus 4 here as well, and a difference of plus 4 over here. That means we have 4n. All we need to do now is take things back a step. So what we need to do here is add a 4. We'll be subtracting a 4 in terms of the fact that we are going back a step. So what we will do is negative 10 minus a 4 instead, actually, because what's going to happen is if we're going back a step, we are just going to have to multiply by a negative 1. So that means negative 10 minus a 4 will give me a 14. Overall, that leaves me with this 2n squared, this 4n, and this negative 14. So we've got, therefore, 2n squared plus 4n minus a 14, just as the question asks, so QED, and that is the correct answer. Now let's go on to part 2. Hence, find the term with the value 272. So, we're saying that 2n squared plus 4n minus a 14 will give me 272. So we need to just find out what values of n will fulfill that. So 2n squared plus 4n minus 14 minus a 272 will give me 0. Now if we can simplify that down, which we can, 2n squared plus 4n minus a 286 will give me a 0. Now I'll just pop that into a calculator really quickly to make things quicker. So we have a, b and c, so we can use a quadratic formula. So we have 2 as the a, 4 as the b, and negative 286 as our c value. Now that on the calculator has given me n equals 11 and n equals negative 13. So we've got that and that as our answers.